All righty. Well, thank you so much, everyone, for coming today. It's good to see a lot of faces. My name is Tori Scheidt, and I'm a first semester applied climate MN student. And my project, as Jeremy kind of introduced, is about flooding and excessive heat in Detroit, Michigan. I first kind of want to give you guys some background on kind of why I ended up choosing this location, and kind of what specifically the national look at flooding and the flooding and excessive heat, and kind of more the Detroit Central. So flooding across the US is kind of going to significantly increase. From the National Climate Assessment, it indicates that heavier rainfall events are expected to increase across the nation in a very likely and very high confidence range. And then roughly 20 to 46% of increases in observed flood damages can be attributed to increasing precipitation. I realize I am in front of the screen. The little red boxes are kind of just the general area where Detroit is, just so you can focus a little easier in on it. And there's looking to be, and the total precipitation on heaviest 1% of days, there's like a 20 to 30% increase. And for projected changes in annual precipitation, there's about like 1 to 2 inches. Specifically in Detroit, the impacts can kind of be broken into kind of like three main areas, one being health and its exposure to toxic mold and increased drowning risk, waterborne illnesses, and the mental strain and stress of dealing with, safety and your property being damaged. Specifically, the graphic on the right deals with the Detroit's mold problem. Around 70% of homes have mold in them, with a majority of them being with homes that have reoccurring flooding. But even homes without reoccurring flooding still have mold issues from other, kind of more, temperamental flooding events. And then, of course, you have infrastructure damage with flooding. Flooding across the nation is the most costly natural disaster. And so stormwater and sewage backup, due to the aging and insufficient equipment, are one of the biggest problems in Detroit. And of course, water damage and destruction of homes, roads, and businesses leads to the disruption of daily life. If you have roads that are flooded, you can't get to places like work and school, which can cause stress for missing work, missing days. So there's a lot of kind of connections between these, and they all kind of compound to make big effects. So excessive heat across the US. Heat waves have become drastically more common, especially in the West, but can kind of be seen across the United States as well. And then a newer kind of impact that has a lot more damage than one might think is that the nighttime temperatures are rising faster than daytime temperatures. And a number of nights when the temperature, there are a number of nights where the temperature never falls below 70 degrees is increasing. I just wanted to quickly show kind of what the National Weather Service heat index kind of looks like, and how the relative humidity kind of affects. But even days when it starts to get in the 80s can quickly become, extreme caution or dangerous. And then two of these kind of graphs on the right, I wanted to show that the number of days above 75 degrees Fahrenheit are going to be increasing in Detroit around, I think, 5 to 10 days. And then warm nights are supposed to increase around 10 to 15 days as well. And then specifically in Detroit, the health and disruption of daily life are also key points. For health specifically, there is a lot of heat stress, heat stroke, cardiovascular and respiratory diseases are often exacerbated. And then children and elderly are very much at an increased risk. This graphic on the left kind of shows where there are, urban heat hotspots. And these hotspots are kind of due to infrastructure changes and the lack of green spaces or shade or kind of just general airflow. and kind of shows that there are a lot of people that can be affected by a very dramatic increase in temperatures. And unfortunately, the mortality rate is generally increasing as we see the climate continue to change. So why focus on Detroit? Detroit is kind of our, next door neighbor, and it kind of it's easier to relate and see the effects, but also because there is a very, very vulnerable population. Upwards of 77% of the population is African American. And on this graph on the right that focuses more on flooding damages, we can see that traditionally, like Black residents experience a lot more average annual losses in flooding. And so if you have a city that's mostly made up of that population, you're going to be experiencing a lot of greater impact. It's also an urban setting, which conveniently does not handle flooding or heat very well. Flooding doesn't absorb water like as effectively as natural landscapes do, and heat materials trap in heat and cause that urban heat island effect. We also wanted to focus on Detroit because they're actively trying to create reparations for the city of Detroit, and there is a reparations task force, and it's focused on creating a better future for Detroiters. And there's a harms report that is being constructed by the University of Michigan's Center of Social Solutions. And they're working on quantifying all of the previous harms done by Black Detroiters and any of minority. And climate can be easily implemented to help create a lasting effect, a better lasting effect to any of the solutions that the Reparations Task Force is trying to do. And there are existing initiatives that might not be enough. So kind of working to get climate getting policymakers to think in the climate perspective of the changes that they're so painfully trying to do, right now. Let's make sure they last. So now we're going to kind of go into my involvement, which I won't lie is a little bit minimal, mostly, but we'll go to the kind of the roadblocks and kind of my future ambitions later. So it was talked between, me and the project advisors about creating more of like an executive summary on excessive heat and flooding in Detroit, just so that it's, kind of actionable and usable information, not a super long paper that will take, a good scientific background to realize. But it also could take more an effect of a spatial modeling and mapping mindset, focusing on specific areas, seeing where there's overlap between flooding and heat. And, and in another class, we focused on also air pollution, kind of those trifecta zones that really need specific attention. And possibly using, what Caitlin just did, showed you in more of like an ArcGIS story map. My potential, kind of partners and clients have been the Rackham umbrella course. And I got to network with a lot of people doing work with the arms report and other interdisciplinary sources. A lot of what I mentioned has a lot of, the health and the structural design is very inherently interdisciplinary. So learning information from them has been very helpful. And I recently, and I mean like Monday recently, had a conversation with the Center of Social Solutions and where the meeting talked about specific projects they kind of had ideas for, but have put on the back burner, including looking into green infrastructure, historical flooding, and news media and how they intersect. Specific stakeholder mapping, and then more on public health. So these are probably going to be projects that I'll be kind of shifting towards or kind of building something off of those ideas. And kind of what I've started at the beginning of this project, I've done a whole bunch of literature review, kind of roughly analyzing some of the FEMA maps and trying to locate data, as Caitlin kind of expressed already. It's hard to find data. And I wanted to play around with some excessive heat graphs. So this is one graph I made that kind of shows the average amount of days in a year with signs of excessive heat. And I quantified those as, days above 90, days above 100, and then no relief, which I defined as the minimum temperature for that day was above 75 degrees and then the maximum temperature for that day was above 90. So we can see that the city airport, which is kind of more in the city of Detroit, experiences way more no relief days. And that's in an area with even greater airflow because it's an airport. So I can only imagine if I can get my hands on some really, good, in the city data, that this would be even more. Uh-oh. Nope. Uh-oh. Okay, there we go. And so here are some kind of like my working through my challenges. I had a lot of trouble getting in contact with the people I wanted to get in contact with. But I think we're on the right path now, of course, right, right when I'm making this presentation. It's also a politicized topic of reparations, and that can be hard for people to want to communicate with and for. And I've also kind of already communicated the data issues. And I was personally struggling with, what direction do I want to take this? There's so many ways you can take this. And I think I'm starting to find that, finding my stride now. Luckily, I have an interesting time frame for my project. And so I do have the summer to kind of get myself set up for success in the fall semester when I will be continuing to dedicate a lot of my time to this project again. And I can do some more of those time-dependent tasks like finding data and like asking people for data kind of over the summer months. And for the future, my personal goal is to develop a product that provides present and future climate information about flooding and excessive heat that is usable beyond the scientific community. I want it to be accessible, and people can obviously use it. And so, immediate next steps are continuing to reach out, continue defining data, continue to learn more by researching literature, and then experiment with things like ArcGIS. That is all. Thank you.